All right, so hopefully this presentation won't be very technical. There's no standards, there's no maths and no equations. But it was really interesting listening to Rob and Alex and thinking, yeah, those are exactly the sorts of things that I'm thinking about when I think about risk and responsibility, because this is kind of a bit of a hot topic for me at the moment, because I'm seeing that the regulations are going much more into a risk direction, but also industry has sort of evolved into a situation of risk, and I'll explain why in a moment. So, you know who I am. So I'm going to talk about risks in compliance. And you might be sitting there thinking, I didn't know there were any. And you might be sitting there thinking, this is okay, I don't take any risks in my compliance. But maybe 30 minutes from now you'll be going, all right, maybe I am taking a few little risks. I'm going to focus on the USA and Europe because I've already talked about them. So obviously you know the basic concepts of those. I'm going to talk about the risks that a manufacturer might take, and therefore that will lead to some of the ways that you might choose to reduce or increase your risks. This is all really based on a change in our industry over the years. I'm also going to touch on the Radio Equipment Directive's risk assessment, because that's not only is that an embracement of your risks, but you've actually got to write some stuff down, and this is a mandatory document for anybody selling radio equipment into the EU, and then some common mistakes. Okay, so firstly, why do you even do EMC and radio testing? Well, as I said just before ice cream time, it's so that you can sell your products, right? You come along, you don't have some sick obsession to watch an ESD test. Who does? You just want to sell your product. But when you're developing your product, you might have interest. So, you know, the people who make the fan or the cooling in your product, they might say, well, how much current does your power supply draw? What's your average power of your transmitter? So you might make measurements for your own purposes, so you can say to your battery dudes, my transmitter transmits this much power on average. And that kind of testing, you can do whatever you like. That's your own information. But as we discussed this morning, when it comes to selling your product and you've got these regulatory compliance steps that you've got to jump through, usually you've got to test in exactly a way that is prescribed in the standards. So when you go to a lab and say, measure my average power of my transmitter, I think it's about 1 watt. And the lab goes, well, we've got to measure it exactly this way using this exact method for regulatory compliance. So it sounds like everything's really, really clearly defined for regulatory approvals, and it's kind of taken out of your hands. You give your product to the lab and go, test it please, and I'll be outside with my mint choc chip. But actually, there are some choices you've got to make. There are some decisions you've got to make, and with choices and decisions comes risk. So, risk in compliance. Surely there is no risk. If anybody has ever read the FCC rules, the word risk doesn't jump out at you. It's like, my analogy for the FCC compared with Europe is, let's say you've got teenage children and you want to go out and you don't want your teenage children to have a party. The European approach is like, as you leave, go, hey kids, please don't have a party. And you go out. And when you come home later, if there's just empty beer cans and curry everywhere, you're like, you had a party, you're in trouble now. Whereas the FCC's approach is like locking the doors and taking all the beer out. So, you know, you're forcing that it can't happen. But even so, there is some risk. So it doesn't seem like it. The rules seem really, really clear. You read the rules, you go, I must test this way, my product like this, the measurements like that. Wow, there's no risk for me in there. The test lab tests very clearly, following the procedure in the exact standard that you've been told you've got to test. So, well, that doesn't sound very risky. And so then it leaves you with this kind of approach of, if I've passed the tests, I can sell my product. So you take your product along, you give it to the lab, you go for your ice cream, you come back, they go, here's your report, it passes, and you go, great, I can go and sell my product now. But it's not that easy, because as I said this morning, just because you've passed your tests, there's still an approvals bit to go through. So why would there be an approvals bit to go through if it's all about just passing a test? Well, here's a few things. Firstly, any failures from your product, when I say failures, I mean like it going into an unsafe mode, or it causing interference to something else, or something else nearby it causing your product to stop working, or any of those things, they're designed in. If your product could fail, you designed it to do that. By accident, I assume. But all right, this laptop, right, it's sitting there right now, and it's showing PowerPoint presentation. It might have Wi-Fi connection. It's got a cable for its power supply. It's got a cable to the projector. It might be backing up its hard drive. It might not. It might be at full brightness. It might not. Who knows if the speaker's on. But it's got a combination of events. That laptop has probably got hundreds of combinations of possible events. And the manufacturer, ThinkPad, they will have tested some of them. If it ever failed, it's probably the case that just the right combination of events would have caused some failure. And it wouldn't be some random accident. It would be like if you found that combination of events that caused a failure, you could go back to that combination of events over and over again, and it would always fail. So if your product has some weird combination of events that causes a runaway, a safety risk, or an interference, or it to stop working, probably it will always do that in that mode. Probably you will never know, because you don't stumble across it in the test lab, and nobody ever stumbles across it in the real world, and so you'll never know. But failures are designed in. They don't just happen by accident. So your product might have some failures within it, in its capability, and it's a responsibility of you as a manufacturer to check that that isn't going to happen. With Europe, the Radio Equipment Directive, in your documentation, you have to document everything you've done as part of your risk assessment to explain your compliance approach. And if market surveillance ever comes to your product because they want to audit it, or maybe your product causes some interference and somebody complains, or you get too many consistently bad reviews on Amazon or whatever, one of the first documents market surveillance will ask you for is your risk assessment, because they want to see which approach you took. Test reduction then, just listening to Alex, you might go, well, we don't do test reduction, we do full testing. Full testing, complete full testing, we don't do any test reduction. Go, great, okay. So let's say you've got a radio transmitter, you test bottom, middle and top channels. Well, Bluetooth is 79, 80 channels there, so that's 3 of those channels you've tested, and you're making an assumption that all of the others comply. This laptop was probably fully tested in 1 or 2 modes, but we've just said it could have hundreds or thousands. It might have been tested with a fully shielded HDMI cable, or maybe not, but people will have made a decision. And the classic case of where most people take the most risks is if they take an approved radio module and they install it into something else, and they say, I'm going to do some spot checks, but I'm not going to fully retest everything, because that looks like a lot of work to fully retest a radio module. So that's like a massive source of risk for anybody doing that. And we'll come on to that in a minute. But if there is a failure somewhere designed in your product, you could look like you've passed all the tests by testing 1 or 2 modes, and then you're selling your product. But how do you know if your customers all find that failing mode, your product's going to get awful reviews, maybe bad press? You know, if it's just some sort of harmless commercial product, then people will go, this product's awful. Every time my neighbor unlocks their car, my doorbell records my cat walking past the street. Or, you know, every time I'm trying to use my medical thing and I press the button, you know, my microwave starts working, and then suddenly I can't use my Bluetooth anymore. My kitchen, I've just had my kitchen done. I knew my old microwave door was leaking, because every time I used the microwave oven, my Bluetooth speakers in my kitchen stopped working. So there we go. So I'll start with the FCC. Risk is not really inherent. You read the FCC rules, and it doesn't talk about risk, but it's almost like a byproduct. They'll say, if you do these tests, then your product is authorized. So that sounds brilliant, but they'll say things like, test it in its worst case mode, or test it in its worst configuration, or test it in its worst condition. So that's where the risk exists, because you turn up to the lab and say, here you go, Alex or Rob, I've set my product up, I've connected the cables, please test it like that. And the accredited lab will go, okay, we'll test it like that, here's your report and it's authorized. And then did you set it up in a way and did you connect the right cables in a way that you know that was your worst case mode? In Europe, it actually says in the red, you've got to write all this down, you've got to think about this, this is an important part of the process, because you're not certifying it based on a test in a standard, you're authorizing it by signing your DOC. So, well, we work for a test lab, we don't work for a manufacturer, so why do I even care about this topic? If you give a product to a test lab, we're supposed to just test whatever you tell us to test, we'll do the test, we'll give you the results, and then, that's our job. Maybe for me as a notified body for the EU, and I'm also an approved body for the UK, so I do end up doing a little bit. I have to read manufacturers' risk assessments, and I have to kind of share their decisions. But for the most part, it's because historically people used to come along and go, I want to buy a test, here's my product, I want to buy a test that, give me my report. But more and more people say to us, I want to put my product on the market, what do you think I should do? Or please help me. They didn't call up and go, I want to buy an emissions test, please. They call up and go, I've got a product that does this and I want to sell it to Europe. So we're kind of dragged along on the journey with you. So as I said, you've got this test and approvals, two separate topics. So you get your test report and you think, right, I've tested and I've passed. But as I said, that's not the only thing. There's approvals. And what it is, so let's say for the FCC, you've done your testing. If it's an DOC device, as soon as you've finished your testing, you choose to put the compliance statement in your report which says, my product, in any of its modes, will comply with the FCC rules based on the testing I've done. Or if you're getting it certified, when you send the test results to the certification body, you also sign a form that says this test report represents the absolute worst of my product. If you're going to Europe, you get your test report, you look at your report and you sign your DOC based on your report, and your DOC is saying that based on my one test here, all of my other products I sell will comply. Because you're not actually selling the one you tested anyway. So, your report represents all the ones that you're going to sell. So let's have a quick look at the USA. So testing is clearly defined in the standards. As I say, it goes, right, here's the standards, here's the test method, do not deviate from it, do the right thing. But then it says for things like cables and test modes of operation and things like that, it sort of says set it up the worst way that you know. So it's quite subtle in its way of saying you must test like this once you've set your product up in the worst possible way. When you go for certification with a certification body, has anybody here ever handled a project to a TCB or a certification body? A few tentative little hands there. So there'll be forms that you had to send in, and you'll have had to send in the documents. You'll have had to send in the block diagram, the parts list, the technical description, photographs, user manual, test reports, and there'll be certain sort of quality of documents that you must send in. And actually the FCC rules are very clear. Often I'll say to people, I need the block diagram and it needs to show all the frequencies at every stage. And they go, what? Why do I need to send that? I go, well, it very clearly says so here in the FCC rules. The TCB's role is to check that everything is there. And as a TCB, I probably have heard 100 times, another TCB never asked for that. You're being stricter than the other TCBs. But if the FCC rules are really clear on what must be there, I've never made anything up that was above and beyond the FCC rules, because I have to assume that other TCBs have been happy to certify something based on less than the rules require. So doing that is a risk by the manufacturer and a risk by that TCB. Really though, you should look at the TCB not as some sort of hurdle. I never like to see myself as like a brick wall going, you can't sell your product till you get past me. I prefer to look at it like the regulation is the wall, and I'm there with a ladder going, let me help you over this wall. And that's how you should approach the TCB and the test lab, as a sort of partner where you go, right, here's as much information as I've got as possible. do you see anything wrong with my product? And the more you share with the TCB, you might go, whoa, there's something here which really makes me nervous. Have you considered this? Yeah, shit, that's a mode I did not think about. So if you make a change to your product, as I mentioned, you might have to do some retesting, permissive changes for the FCC, but it might be partial retesting. You might not do full retesting. And that is another source of risk by the manufacturer. You've got something like the laptop here, maybe it's got 3 USB ports on it, and you have a new version with 4 USB ports and a slightly bigger screen. You don't want to retest it completely, but you'll maybe check some emissions. So straight away, you're into a conversation there where you've gone, I'm not going to fully retest it, I'm going to do some partial testing. So you're just opening up a whole world of risks, which is not a problem. That's absolutely okay, and it's how it's all set up, as long as you go into it with your eyes open and document all these things. So if you've got a radio module, so let's say for the FCC, you've got a certified radio module, it's got its own FCC ID on it, you install it into an end product, so you don't need to recertify your product because you can put contains FCC ID onto your host product because the module is certified. But you've still created a new product now, so you've got to do some retesting of the transmitter mode of this new product you've created. But you might say, you listen to Rob's presentation and you say, well, Rob said most of the radio testing is conducted out of an antenna port. Well, I haven't changed any of those things because I've taken a module and I've put it in, and those things are identical. So I'm going to get the module's test report, include them in mine and say, that's it, it's covered, that's the same testing. But there's also the radiated spurious emissions from the transmitter mode that Rob mentioned. Well, anything could have happened there. So I'm going to repeat that. That's the manufacturer's decision, and that's a good decision to make, in my humble opinion. The antenna of the radio module could be interacting with a host. You really need to think about that. And if you say to me, what tests must I do? I shouldn't just stand here and go, do this. I should say, well, what is your product? How does it work? Things like that. The final product must comply. If you've decided not to do those conducted tests yourself, that's a risk and it's your own decision, and you've got to think about why you did it. There is not one definitive list of tests. If you install a module into a product, you won't find anything that says you must repeat this test, but you also won't find anything that says here's some tests you don't need to repeat. The FCC has a guidance document, they're known as KDBs, that says, for example, you've got to check the end product complies. For example, transmitter radiated emissions should, that would be a good idea, that sort of thing. Doesn't mandate it, but it also doesn't say, don't worry about the other tests. These are all the manufacturer's risks. And it is the manufacturer's choice. Often a manufacturer will phone us up and say, we've installed a radio module into a product. What tests do you think we should repeat in the transmit mode? And as a sensible lab, we should say, well, it's up to you. What do you want to do? Actually, manufacturers don't want to hear that, and it's not a conversation they want to have because they know that they could phone somebody else up and the other lab will go, oh yeah, just repeat transmitter tests, so the spurious emissions test, that's fine. They go, wow, that was a much easier answer. I'm going to go with a lab that gave us an easier, albeit incorrect, answer. Whereas the correct answer doesn't always sound very comforting. So you want to be able to understand, okay, we would recommend this, but are you okay with that? Because it's your choice. So as a test lab, we end up advising, but I think sometimes it's important to remind the lab that we are advising you, and you should be going, yeah, okay, that is what we want to do. So let's move quickly across now to Europe. A quick reminder then, so all those same things apply, the same logic. Everything I've said about the FCC applies, but now we're applying it to product safety, EMC performance, radio performance, and in the future, these other things such as cybersecurity. This one's going to be crazy for risk. Like the laws of physics, I'm pretty old and the laws of physics have not changed in my lifetime. So I'm confident they're quite steady. If you do a spurious emissions test now to a certain limit, your product might change a little bit, but the way that electromagnetic fields radiate through space is probably not going to change much over the foreseeable future. But the way that hackers hack into the software of a product, that is going to change, probably on a minute-by-minute way. One of my big concerns about writing standards for cybersecurity is the fact that as soon as you write it down, everyone will know what to focus on, you know? And they go, oh, okay, well, just make sure we know that everyone's going to be doing that. They won't be doing the thing next to it. So with Europe then, this whole CE marked radio module, there's no modular approvals. You put a module into your product, you're responsible for fully assessing the end product. And you might say, well, actually, safety testing I'm always going to do fully on the end product. That's a given. EMC, emissions and immunity, I'm always going to do fully on the end product. EMC immunity testing of a little module bears no resemblance whatsoever to EMC immunity testing on an end product. So those results don't correlate at all. But there could be cases you go, well, again, as I remember Rob saying, and Rob seems like a pretty clever guy, he said that those transmitter and receiver antenna port tests, they're just conducted out of an antenna port. So I'm going to choose to sort of trust those. And so, in fact, a lot of installers of radio modules repeat, full safety test, full EMC testing, but then the radio performance, they might say, I'm going to contact the module manufacturer, get their test report for the radio performance, and then I'm going to trust their antenna port measurements, and I'm going to just repeat the radiated spurious emissions test. And that seems fine. I do end up with some funny conversations with people where they'll go, oh, well, the radiated spurious emissions test, it will only ever be better than it was on the module. And I'll go, okay, why is that then? And they go, well, the module was tested open. And so as soon as you put a module in something else, it's bound to provide shielding. So the emissions coming off the module will be better. You're right, okay. So your receiver testing will be worse then because the host provides shielding. Oh, no, it doesn't affect actually any of the signals. My host product is invisible. Okay, so it doesn't make the emissions better. Damn it. So you're responsible then for looking at what could possibly happen. So again, for Europe, no one definitive list of tests you must do, but also no lists of tests you don't have to do. The test lab can advise, and we do advise regularly, but ultimately it should be a manufacturer saying, okay, this is the decision we want to make. I find manufacturers take different approaches to this. Some labs will go, right, we've installed 3 radio modules into our product. What we want to do is absolutely minimize our testing. So we've got compliance managers that know all about EMC and radio. We've employed a consultant. We want to pay Element some advisory services. We want to spend the next few weeks going all over the test reports to find out really how we can minimize the amount of testing and spend the least amount of time as possible in the lab. Other manufacturers go, well, we don't have a consultant, and we don't have an EMC and radio expert, and we don't have a few weeks, so just test it. Retest everything. Even if it's not necessary, it gets it to market. Because time to market is the most critical thing. As compliance managers, you probably have a boss saying to you, please do everything you can to reduce your testing and certification costs. But what they really mean is, please do anything you can to reduce your testing and certification costs, but whatever you do, do not let launch date slip, and make sure the product is fully compliant when that launch date comes. So that's what they really mean. Because getting a compliant product to market, once it's on the market, the money will be coming in a lot faster than you were paying it out to a test lab. I've seen manufacturers spend weeks trying to justify not performing a half-day test. And I don't always understand the logic, except for the fact that their testing budget was really closely scrutinized, and their salary time of their team probably wasn't scrutinized the same way. So if you start putting multiple radios into a product, it becomes even more complicated because the radios will start to interfere with themselves. If you've got a radio module and the receiver testing passed really nicely of that module sitting on its own, say it's an LTE module, and then you buy in a Wi-Fi module, and that module's sitting on its own, receiver performance really good, great, And then you buy in a GPS module, and that one works really well. And you put all three of them into a product, and you go, I'm not going to repeat the receiver testing because each one of them passed perfectly on their own. Well, okay, so let's say it's an 800 megahertz LTE module. The second harmonic is at about 1.6 gigahertz, which is where your GPS is, and the third harmonic is about 2.4 gigahertz, which is where your Wi-Fi is. So suddenly, those receivers might be really compromised, and all the electronics in it. So at what point do you say, do you know what, let's go and repeat the receiver testing on the end product? And again, for Europe, that's completely your decision. And even not just, I'm not just talking about market surveillance and regulatory thing. That doesn't really matter. I've got a slide on that in a moment, but the risk of market surveillance is not your biggest concern. The biggest concern is your product does not work well in the real world. You get bad reviews, you get bad press, and nobody wants to buy your product. That's much more of a threat than market surveillance. So test and inspection and certification, tick, that's a lab-like element. How are we linked to it? Well, choosing a good lab and choosing a lab who understands, who's prepared to have this kind of conversation with you. If you've got a complicated product and you ship it to a lab and then they send you back a test report without any questions asked, you've got to wonder how much did they really care about how your product worked and how much of an interest did they take in it. So as a manufacturer, what sort of risks are you taking? Some risks might be calculated. So you might have all these different modes, and you might have done some research and some pre-testing to find the worst one. You might use that information to calculate a worst case. Like you might calculate that your transmitter has lots of modulations, and some of the tests, the highest power mode will be worst, like RF exposure. Other ones, you might decide the widest bandwidth of the signal might be worst, or the most complicated modulation scheme might be worst for receiver. These are like calculated risks you might take, and that leads to like test reduction. But I also see a lot of risks made by people without any technical logic or justification involved, where a bunch of people in suits would sit around in a room and go, well, we've got these 5 models, that one's the biggest, so we'll say that one's the worst case. I remember being asked to certify a family of models. One model had two buttons on it, one had 4 buttons, next one had 6 buttons, the next one had 8 buttons. And the buttons were all metal and they had different PCBs underneath it. They tested the 8-button version and they wanted us to certify them all. And I said, where's your evidence that the others passed? And they said, well, the 8-button one was the worst case, so we just tested that one. I said, oh, brilliant, thank you very much. Send me the evidence that that was the worst case one, and we're good to go. I went, well, we haven't got any evidence, but we just think it will be the worst case. And I said, why? And they said, well, 8's the biggest number. And I was like, that's really not a great technical justification. So you can do these things, but don't just think about it. If you make 100 or 1,000 radios, I'll guarantee you test them all, they'll all have slightly different output powers. So the one you take to the lab, how do you know that it was really the worst case or the highest power level? And do you know every possible mode? Do you really understand how your product works? So the manufacturer's risk assessment, you are expected to document everything. Now you might think of the risk assessment as you go through your whole test and approvals, and right at the end you're like, oh God, Michael said I've got to write a risk assessment, where do I start? Well, you should have been writing it as you go along, and you probably have actually, because you probably will have said, hey, let's make this product. It's going to go outdoors. Kids might use it. Or let's use this safety standard, this EMC standard, this radio standard. We'll set it up this way. Maybe we'll connect some cables to it. And then at the end, you go, oh, God, how are we going to write a risk assessment? All of that information, that's your risk assessment. That's what you're doing. It's not like, it doesn't have to be a grid of boxes. It just has to be an explanation or a journal of how you got to where you got to. It's written in the red that you have to do it. The notified body would ask for it, and market surveillance would ask for it. But use it as a helpful tool. Don't use it as some sort of horrible punishment at the end. Use it as a good guide, like project planning. So the manufacturer's starting place, think of things like who's going to use it, where it's going to be used, The red says products have to be compliant for the reasonably foreseen use. So there's no kind of putting in the user manual, you've got a phone, don't ever power it from a car USB port, please, because we didn't do vehicle transients. That's not real. Everybody plugs their phone into their car all the time, and so not doing vehicle transients on something that's USB powered that somebody might take in the car is just crazy. If you've got harmonized standards, it gives you presumption of conformity, as I explained this morning. If the standards are not harmonized, you don't have presumption of conformity, so you put in your risk assessment why you chose that standard. And it might be a really simple reason. So, frequency ranges of tests, which cables, which ports, which types of cables, which modes, how you monitored your product during EMC immunity. These are all the types of things that you can throw into your risk assessment, and it pads it out and it looks good. But it's also very useful for you to be able to stop back. I always think a safety risk assessment is really like a grid, like the likelihood of it happening versus the consequences of it happening. And if it's green, unlikely to happen and no bad consequences, that's all right. And red is very likely to happen and horrible consequences if it happens. That would be red. That's very much a safety risk assessment. Your red compliance risk assessment, I always think of it like you're going out and you get to the front door and you go, did I turn the oven off? Did I lock the windows? Have I fed the cat? Are the kids in the car? That kind of, have I done it? What didn't I think about? So when I first started radio testing, 20-something years ago, people used to come up to me and go, I've got this radio. It transmits at this frequency, at this power. If you press this button, it will transmit with this modulation, and this is how it works. Please test it and certify it and give me the certificate on Friday. You go, right, brilliant, thank you. Nowadays, people come along and go, yeah, I've got this thing. It's really cool. Kids are going to love it. Does all this colourful stuff, screen, internet access. I've thrown in an LTE module, Wi-Fi, Bluetooth, LTE, and it's wireless power transfer. Not really sure what to do next, but please certify it and give me the certificate on Friday. So the industry has really changed because you've got like the Internet of Things where the manufacturer is an expert at the thing, but they're not radio experts. So if this projector is radio enabled, I'll bet you the manufacturer knows everything about projectors and nothing about radios, and yet they're authorizing a radio equipment to the Radio Equipment Directive. So our industry has changed from radio experts to thing experts installing radios. So I know I'm running on, I apologize, it's my style. Old dog, new trick. So one thing I would say, the old days where you would say, got the golden sample, you'll take to the lab because this one, we know it passes really good. The emissions from this one's really good. Don't touch the golden sample, that's the one that goes to the lab and the emissions look really good. If you've been listening in the last half an hour, you might figure out that that's not a good idea because the one that you test represents the worst of everything you're ever going to sell. You're testing, not because your test report has any value, spoiler alert, in my opinion, and it's a strange thing for a test lab to say, but your test report has no value whatsoever other than to give yourself confidence that every product you ever sell will comply and won't cause problems. So if you've tested a golden sample, it's like you're just kidding yourself. I'm going to patent this term, I think, but you should test your rust sample, like your absolute worst. And we have customers who spend months doing pre-compliance testing with us. They'll test 40 or 50 samples to find the worst one. And they might go, oh, this one's got worst in Bluetooth mode. Do Bluetooth testing on this one. This one's got the worst emissions, and this one's got the worst LTE performance. So test those. And that way, if anybody asks us for our reports, we know that those represent the absolute worst and that everything that rolls out of our production line will only ever be better than that. And the same with output powers. If you test something that's low power and then you're selling something higher power, you could have problems either with customers or with customs. And this statement as well, Alex said that this thing might have 30 modes, which that's too many modes to test. And people will say, my product's got too many tests, too many modes to test them all. Well, there's nothing in the regulation that says if you've got more than 10 modes, just stop testing. It's simply the manufacturer's choice to look in their wallet and go, all right, let's stop testing. So that's a risk decision. This slide, I'm almost finished. This slide I threw in at the end where I was at a workshop recently, and they were talking about something Rob talked about, which was intermodulation products. Let's say you put LTE and Wi-Fi into a product, right? The rules say if you've got multiple radios, the rules are very much written around a radio. So you test the LTE, and then you test the Bluetooth. And the FCC rules does have a little statement that says if there's multiple radios in a product, you have to have them all on during the testing to make sure they don't interfere. The red doesn't specifically state that because the red doesn't tell you how to test. It just says your product will comply. But even with the FCC, that rule clause is quite hard to find, and it's just a sentence, really. And so at this workshop, and the FCC were talking about the test that you do to check that all of your transmitters on at the same time don't cause problems. And people were going, where? Where does it say I have to do that test? And the FCC were like, well, it says here that, you know, we've got a combination of radios, it must pass. People go, yeah, but where does it specifically say I have to do that test? And I thought, this is crazy. This is like a little child doing hide and seek, where if they block their eyes and they can't see you, then you're not there. So it's like you're saying, you know you've got to sell a compliant product. How will you know that that mode passes if you didn't test it? You shouldn't go, where does it say I have to do this? You should come about it the other way. You should go, I know I want to sell a compliant product. It doesn't say anywhere I've got to do this test, but I can't think of any other way of proving it. So I'm going to do the test because I need to prove I've got a compliant product. It's almost like if I don't do the test, I'll never know that it would have failed, and then I'll be okay because I'm all right then. I never did know. If I don't look, then it doesn't exist. Okay? But how else will you ever know that it could have failed in that mode? So that comes down to knowing your product. You might only have to do it once. All your future products, you go, we did that once, it made no difference, and we wrote it down. Look in our risk assessment, it's right there. So some common mistakes: lack of planning, lack of pre-testing, not knowing your product, wrong company, wrong role, manufacturer saying to a lab, you just test what you think you should test, and then later on going, why don't our products work? Thinking it's simple, not knowing your product's own worst case. Plan early, engage early, don't just turn up at the end and go, did it pass? And as I mentioned, my whole point, it's not about market surveillance. You're not worried about getting told off by teacher. You're worried about having a best product on the market. So, but the fact that you're not just sitting at home sending your product off to a lab and saying, give me the report, please. The fact that you actually come here, I heard somebody earlier say, they've got to start making this type of product, so they've come along to learn. If you didn't care about your risks and you didn't care about your compliance, you wouldn't care about learning. You'd send your product to the lab, but you're here because you want to learn and you want to understand, which is a good step towards making sure your products are the best, in my opinion. There we go, lunchtime. I'm only 8 minutes late, sorry.
That's all right.